Hey guys, welcome back to this new tutorial for the STM32F1, and for this one we are going to go more in details and using an advanced strategy to manage the Nokia n5110 and to have an output as animations. Quite exciting, isn't it? So by the end of this course you will be able to develop the same app as you can see here, so something, a message or a picture when it starts, and then you'll be also able to make this a small simple animation in the Nokia screen. And as you can see, you can mix not only animation by adding some text, as this small guy will stop and let us know, yeah, it's just WeeW, and continue the walk. So this is all will be programmed and we will see all the steps together, so stay tuned and enjoy with us. And as usual, so the code that we are going to write together will be available in the link in the description below. So let's go quickly through the tutorial. So first of all, we need to explain what would be this advanced strategy. So we called advanced because there's some logic behind that we need to go through. So there is a small presentation explaining how we are going to do and implement the data, and after that how we are going to upload the data in the Nokia device. After that we are going to start coding, and we need to use for this one, for this strategy, a type or a structure. So we are going to create a type definition and a structure that will help us a lot to implement the strategy. Next we are going to create some function. We are making a buffer and clearing it, so it's just function. And number 4 will be really the two most important functions, because this is related to the upload and the updating of the buffer. After that we are going to upload an image, and we are going to use a Python program to generate a data ready for the upload from a BMP file. We will have more detail during this section. And finally we are going to create the animation. So from hardware perspective, as usual, we are going to use the STM32F1 and aka the blue pill, also the Nokia n5110 screen. Okay, so let's start the advanced strategy. So in the previous video we have been just uploading the data. We had a bundle of data and that was just uploaded in the Nokia n5110, and this is actually an array, a two-dimensional array having 6 rows and 83 columns. So in other hand, if we have a matrix or a two-dimensional array ready and uploaded directly in the Nokia, that will be more useful. So the idea behind that is to take all what we would like to display, as you can see here in the left, and we put everything on that array that we will call a buffer, and we will be updating the buffer, then sending the buffer into the Nokia. This one will be a more efficient strategy, so we'll have to upload the Nokia only once. So it's a Nokia screen, of course, only once, and we will get to put all the data in the array. So from efficiency perspective, this is far way more efficient than the previous method. Okay, so let's see how we will go to make the array. So to build the array we will need images and also strings that we will add to our array. So the images will be a one-dimensional array, but we will have also the two-dimension information. And why we are going to use one-dimensional array? Because the implementation with a structure got very complicated on a microcontroller if we would like to use a two-dimensional array. We will have more details when we will go through the code later on. And then we will also have the string update of the array, so we will put all our data in this buffer, and finally loading the data of the buffer into the screen. Good, so now we went through a quick review of the strategy. Let's start implementing our new Typedef in our C code. I will need, so for the image, I will have to need the unsigned short, because I do have a small image size. H will be the height, this one, height, and also the unsigned, same exactly, short the W, which will be the width. Sorry, let me remove this W. Okay, and after that, here was the most important. We are creating a const, because all the array we are going to add are const unsigned short unsigned char for this one, and that will be, we call it an image, and we will put that will be able to store 10 arrays. Okay, so 10 arrays means I can store 10 image within one data type. Why 10? This is a number that will be enough for us for now, but feel free to choose the number you want. So this variable itself, the last one here that we do have, apologies, let me make the screen bigger. So this one will be an array of arrays where we can start. And the other point, when we do have an image in this that we would like to show in the buffer, we would like also to know the X position and the Y position. So let's call it unsigned short, because still we don't have really a big screen, and we call X pos, which here the X position, and the last one unsigned short Y position. Okay, so now we created a data structure that will contain the height, the width of the image, one array, one-dimensional array that we will create later with Python, that that like a position potentially for 10 arrays, and also the position of X and Y of the image. So we will use all this variable later on to work and update our buffer. So now that we prepared our new type definition and we have the image type data structure, we can jump and start preparing the small function. This is quite easy function for the buffer that we are using to help us to design our code. Okay, let's start with the clear function, which is for the screen itself. So that's quite a very easy function. So it's a void n5110 a clear, and we don't need to input nothing. So it's a void here, and let's write it. So this function will just be sending zeros to the screen, so it will clear or wipe out all the data already in the screen. So if we put here, so we start from the n5110 function, the position, we need to specify that we would like to start cleaning from position 0, 0, and after that we just go, so just let me add the comma, and we just go and make the JP, write JP for the port A, and this is because we need to start have a data update or data control mode. And okay, so PA, yeah, I forgot the pin, which is the pin number 1. And after that we will go for, so let's put here int j, yeah, good. So for j equals 0, okay, j equals 0, j less than 504, we are going to have a j++. So it means that the variable will go through the whole screen, and each time we are going to be sending, so SPI tx, yeah, and we are going to send for each time through the SPI1 and 0, 0. This one will wipe out everything in the actual screen. Good. So this is the first function, quite easy and simple, and we will be quite using it because this is a very helpful one. Okay, next one is to get the void and make a clear buffer, we call it. So this function will be clearing the buffer that we will be using to update the data in the screen. And so then we need to have an unsigned char, and we call it screen buffer, a variable. Okay, and that's something that will have 84 columns here. And let's start working on it. Okay, so it's much simpler. So it's int I and j, and after that for I, let's say for I equal 0, I less than 6, and I plus plus. So we are looping through all the rows, and after that, inside that, we will have for j equals 0 again, j less than, you know it, 84, because we are looping through all the columns, j plus plus, j plus plus. Okay, so what we are going to do is to take every data in the buffer, and we will put screen buffer, this one I, and here j, so we are looping through the whole array, will be equal to 0. And now we have totally created and cleaned our buffer. This one will be used again when we will be updating our buffer. Okay, last one, this is where we start to print the buffer in the Nokia screen. So first of all, when we create it, so it's a void and it's a print, so it's exactly the same like this, just instead of a clear will be print. Okay, so we print and print buffer. We will be using on this one the clear buffer function here exactly. So clearing buffer of the screen itself. Sorry, it's not a clear buffer. No, that's a mistake. We have to clear the Nokia. That's the most important, as we need to clean all the data inside before we start updating. Next one, we will select the position 0, 0, same as for this one, because we need to start printing our array from really the beginning of the device. And after that, we just use same logic here, and we need the int ing. We go here, and so as we are going now, not really to, so let's cut this one, put here, and same as the clear, so the tx here, we will be sending each time using tx function each time like this. So we will go looping through all of the data and sending the buffer. Before jumping to the next section, just one thing, one miss that happened is before printing in the buffer and start printing, we have to put this port A high and also port A low at the end of the update. So this will say to our Nokia screen that we are going to update the data. So we'll go this one low. Okay, good. Perfect. So then let's save the data here in the H file quickly and save our function here. 1 and 2, so we will be ready to use it later on. 2 and last one, 3. So we could quickly move on with the clear the screen buffer and the printing the buffer. So now we are going to take a look on how to update the buffer and also how to add a string to the buffer. Great, so now we can go for the updating the buffer from image perspective. So normally what we are going to do, so it's a void function, we have nothing to get as an output, and we are going to update the buffer screen, what we call it. Okay, and the first input will be the image type that we created. So image type, and we are inputting the image, and after that we will need to know which image we would like to add, because as you know, in one image type we can input quite a lot. So image, so unsigned short here, what image number we would like to do. I think this will make a lot more sense at the end of the when we will make the example. And finally unsigned char, so this is the buffer that we need to add at the end, like each time. Okay, so now let's start from the beginning. So we do have the position, it's already inside the inside the image type. So we will need some position marker to help us to position the image within the screen. And for that we are adding the X dir, of course the Y dir, and also end X to see where we are ending the update, and we call it X, and Y to see where my image should be stopped, and also a counter, because we have to count each time where we are when we are looping through the image array. Okay, so first of all we need to confirm where is my ending for the X and the ending for the Y. So for the end X, to find it, so we are going to check the image with plus image position for X, so X position together. If they are together bigger than the screen size, then okay, oh yeah, I put a double dot here. Okay, so if together, and it's not ing, it's image. So if together it's bigger, we are not continuing our loop to the end, but my end X will be equal to 83. Okay, so I will stop updating the image at 83. Else, we are going to put end X equal to both the total of both of them. Okay, hope this one makes sense to you. If not, please take the time, pause this video, I'm trying to understand how this is going through. So end X will be equal this together, image and the position, but we are putting -1. Okay, perfect. Then let's jump to end Y. It's exactly the same logic. So I'm going to copy this one here and change everything to Y here. It's the Y position, and instead of 84, it will be greater than 5. And after that, this one, if it's greater, it will be 5 here. So something here, Y position is not accepted. What is the name? It's Y position, yes. Okay, so why this is not accepted? Let's put here, and it's a Y post. Okay, very clear. So let me remove the T and correct it here. It's a Y position here. Okay, good. So let's go back again to the C code. That should be fine now. And this one and Y will be equal here, Y position -1. Perfect. So now we know from where we are going to end and also start. Also the counter, my counter will be equal 0, and I can start my loop quite easy. So for starting my Y direction, this is my counter when I start, is equal to image dot position, the position of y. So this is where I'm starting, because I'm defining where I'm going to start, and my y direction, this one, my y here, is less or equal to end y. We keep going for end y, y direction plus plus. Okay, we keep incrementing each time. So inside this loop we do have, of course, the x direction. So for the x direction equal to the position x, which is this one, image position dot x. This is where we would like to start. So each time we will have until x direction is less or equal, until it's still less or equal than end x, we will keep updating my x direction. We put plus plus. Okay, so let's open here and let's see what kind of magic we are going to handle. So why I do have error here? Of course, because I should close it like this. Okay, so the magic here, now I need to read my array, the image array, as a table, and to read that I have to understand the structure of my table, and this is within the Python program that we created. But generally speaking, the count will be equal for each time. We will have this one, the y direction, this is minus the image y position. So this one at the first would be 0, would be my first line, and that will be multiplied by the image width. So each time I finish reading the whole width of the line, I will jump to the next one. And after that, I have to add my x direction minus the position. So the more we grow, the more we see how the counter will join, and the counter will be each time growing with this factor, which will mean like jumping to the next row of the table. So after we do that, we just have to update the screen buffer and put the y direction here. So we are going through the columns, and after that the x direction, and this will be equal to the image here. This is my array, and the first one is the image number, so which image I would like to go in my array, and after that I just put the counter where I can read it as a table. That's all. This is how I update my buffer, and I put my image directly in the picture. So this looks a bit complicated. If you feel overwhelmed, please take a break and try to understand it again. Else, feel happy and feel, feel really fine to put a comment asking me question. I'll be really happy to answer to them. Okay, let's jump to the next one, which is the updating string. So it's almost same, but we don't need any image type here. So for this one, it's str instead, and I don't need an image type. What I need here, I need to put the position where I would like to put my string. So you can create also another type where you put the position to, but that will be a little bit overcomplicated for this tutorial and taking more time. So, and let's also input the y position, which is the column, sorry, the x position, which is the column, and finally adding a char of string to implement in the into the buffer. Okay, so let's jump. Yeah, not just a gamma, not a dot gamma. Okay, And let's start. This one should be much easier. So we will need some variable I and j as usual, and we would like to count the columns and the row through the buffer. So count col and count row. Okay, so this is the variable I'm going to use, and my count column and count, so my count col will be equal to the the x position, where my count row will be equal to my y position. I hope it start making sense to you guys, and let me initialize the I, which will be equal to 0. Okay, that's fantastic. So the next step will be to go through the string. So while str of I still there, so I don't have any data in it, I still have a data inside it. So let's go and start looping. So first, my first check would be, and that's a very important one, is if the count row is greater than 5, so it means I already have this limit in my counting, so then I immediately have to break. I can't continue my my updating of the screen buffer. So this is just from the beginning. And after that, so what we are going to do, as we have done for the previous function in the previous tutorial, for j equals 0, we do have a j less than 5, because we are going to loop through the ASCII code table. Okay, so first thing to do is to get the update, so screen buffer of count row, so this is, and after that count column, yeah, will be equal to ASCII, the table that we added, str of I here minus 32, and after that the index j, so we can take it stroke by stroke. Okay, but here, even here, I still have to make some conditional statement, so I have to go through if. The first thing to check is count col plus 1 is greater than 83. So if I'm more than the line, I need to jump to the next one. So on this one, we have still checked, because if we are more than 83, if we finish the whole column, we have to check if the position, we have to jump to the next row. But before checking that, jumping to the next row, we have to check if we still have another row or not. So if count, let me put here, count column control plus 1 is greater than 5, so we don't have any more columns. So at that time, we have to break. Okay, else, so what's happening, we can increment the count column if we still have, and for the count, sorry, it's the count row, so if count row is fine, we increment the count row, and count column will be equal, because we need to restart, this is a count, we need to restart again to our x position. Okay, so, and to finish that, else here, let me put it here, else we put count column plus plus. So if I still have in my count column, everything should be fine. Yeah, and yeah, still the last step, if we don't do it, nothing will work, is to increment the I for the whole string. Okay, so as of now, we don't have the image to update this one, but we can make an update for this. So let's first take these two functions to the header file. here, and this one too. Okay, so now we have all the function we need to start having our test. So this is the test from the previous time, and if I take a look to my camera, I hope the code is still working. Let me position it in a better place. Okay, I hope this is quite clear enough. So this is the old code, and let's see with the new code how things will go. First, let me comment this one. Okay, and then let's go to the old code, to the new function that we created. First of all, we have to clear our buffer. Yeah, before that, sorry guys, we have to add this in unsigned chart buffer. This is the one that we are going to use. So this is a 6 column and 84 6 rows and 84 column, exactly the same size as the the Nokia screen. So we go here and we start with the first one. Is we clear, let's first clear the Nokia screen just in case. Okay, and after that let's clear the buffer just in case we do have any issue or some gummy data, some trash data, sorry, it's my Japanese here, some trash data is inside. We need to put this one here. Okay, and after that we are going to update the buffer. So how we are going to update it? So I would like, let's start with a position 1, and here another position 1, and here for the char string let's put hello world just for starting and see what's happened. Okay, and last variable will be the table that we'll make. Okay, no error, so far so good. And finally we just have to print our table to see what would happen. Okay, so let's copy this one here and see what would happen. Yeah, quite chilling. Good, so no error for the moment. Okay, 2 warning. Okay, so yeah, this one ending without a new line. So if I save, and okay, looks perfect. So let's try to take a look on the camera at the same time and see what would happen. So if I run this one, let's make it a little bit smaller like this, and let's upload the code and see, and we do have a hello world. So let's play a little bit more. Let's put line 3 and check. Okay, wonderful. So let's put here line 20, column 20, just to see how things are going. Okay, fantastic. And let's challenge. Let's put it at 60 to see how the word will be written. Okay. Okay, fantastic. You can see that it's taken only that position, and this is exactly what we expected as behavior. So that's really great. So now we do have our function ready. So we just finished updating the 2 functions that update the buffer, one with the image and the one with the string. So actually we have tested the one with the string, but we still have to make the one with the buffer, and that will take us to the next part of our tutorial, where we are going to upload an image and test it. So we are going to convert a BMP 8-bit file to n5110 Nokia screen format using a program, a Python program that has been developed in a different tutorial, where the link is in the description below. So if you would like to get more information about this program, feel free to take a look on it. It's quite an interesting Python program that will give you quite a good insight about BMP file structure. Okay, stop talking, let's go. So we are finally at the part where we are going to see all the fruit of all the job we have been done. So this is the Python file we are going to use to convert the BMP file that we do have here. So this is a weird guy near the wheel, and this is the command line that we are going to use to generate the file. So to generate the file, we just go to the same, we have to put both files in the same folder, and after that, so let me remove here, you have to write Python, and after that you add the Python file name, which is the n5110 BMP converter, and after that you add the name of the file that you would like to convert to a C. So we are going to convert this one to a C readable format, and this will be generated here in a text file. So as soon as I push this one and I push enter, so the first thing you can see, the same picture, the same shape is generated here, and this is a good indicator to show that we are having reading the file with the right shape. And after that there is a text file which is generated, and it generates 3 variable. The first two ones are just unsigned short, when the third one is an unsigned char of 1 array dimension. Okay, straightforward. You just directly copy the data in the file that we created for the C. Okay, we will have an error, and this is because C doesn't accept the high bar, it accepts only the low one. Okay, so fine, so we add the data, we create a new type here. So if I go to image type this one, and I will call it a WeeW pic. Okay, and if it's equal, so what we are going here to do is to initialize. So dot h, the height of this file will be equal straightforward to the number of columns. Okay, no, sorry, it's a number of rows. After that, the dot w will be equal to the columns here, but maybe calls, let's go, yep. And after that we just have to add the positions that we would like. So the x pos will be equal, it's dot x pos will be equal to 0, and the y pos will be also equal to 0. Okay, here, and this is a y. Okay, last step to have here, okay, the camera. Last step that we should have here is to add the array to this new variable. So dot image 0, because we put it an array of arrays, so it's a 2-dimensional array, and this one will be equal to just the array name. Okay, so now we've finally done all the setup, so we can for the moment ignore this one and add the function we created later, which is this function, the update buffer. Let's add it here, and for as an image we are going to use the WeeW pic. This is my image. Let's remove the void, and after that for the image number we are going the 0 because that's the only one we do have, and after that for the buffer we are going to use the same one we used to print the text. And here we are. So let's open the camera and check what kind of result we are going to get. This is the old result of our previous test. So let's make this one smaller, save and run. See, there's 0 error, 0 warning. So if we upload the code, okay, yeah, the error is coming because we put it here. That's a good mistake. We put it here, so we do have only 0 image, and I put number 1. So if we put this one 0 here, and we save and we compile and upload, we can see here that we do have the picture that we start with. So let me make this one smaller here. So this picture is now here, exactly the same. Good. So finally, last thing to update, if we add also this one, and let's put it in the column 5, the last column, and 0 for the X, and if we save, this is the example that we will have. So we do have hello WeeW here a little bit on the top, but we can push it a little bit. So if we add, let's say 15, just to check what's happening. Yeah, and we do have a hello WeeW with text and picture together under the same buffer. Okay, so we could upload an image from our Python program, and this is really quite great. But hold on guys, we are going to the next step. So now we are finally going to the animation test, where we are going to convert few image and use them as an animation. Okay, stay tuned. Fine, so let's start first of all going to the files, the Python converter file, and I added here some file. It's really small, but this is what I call the file Walkman. So I created a 5 pictures of a Walkman, the one stranger than the other, but this is how we will make the animation. So my advice for you is to use the same size for the picture, so you don't have to have any other big change to manage. Okay, so as you can see, this is the Walkman. There's a 4 picture where he walks, and the fifth one where he looks to you. So to convert, as usual, so let me first go to the file, and then let's convert them one by one. So the first one is, so we have to go for Python, and then Walkman. It's the n5110 converter, Walkman 0. Okay, we do have our first Walkman, and the text file has been generated, as you can see here. So let's go quickly through the other one. So Walkman 1, and then Walkman 2, see, quite fast like this, Walkman 3, and the last one, Walkman 4. Okay, great. So what we have to do now is just to copy the text as we do have here. We just copy this and paste in our KL file in the H library. Let's make it bigger here too, where we are adding each time the name and the columns and the name and the size of the array. So to make it quickly, let's divide this one in 2. Okay, and go for them one by one very quickly. So this one, let's adjust the size so you can see how it's going on, but it's really straightforward. Just copy paste. So we have copied Walkman 1, where however Walkman 0 comes first, but the order here is not important, so do not worry about it. After that, let's go for the Walkman 2. Okay, finally Walkman 3 and Walkman 4. Okay, so this is the Walkman 2, Walkman 3, and the last one, Walkman 4. Okay, fantastic here. So we do have everything as we wanted. So let's use this. So now we have all the data. Let's use this to create the animation. Quickly, what we can do and create. So this is before we add this. So we need to create an image type, and we will call it a Walkman. So Walkman, and let's initialize it. So we just need to copy same as the previous other WeeW pick here. So for the H, we can copy here, as all the Walkman have the same number of rows and column, we don't have to worry about, so we just copy the Walkman rows and column for only one. So instead of WeeW stack rows, we will put the Walkman rows, and instead of the WeeW stack column, we can put the Walkman column. So, and whatever the number is fine as far as you are using the same picture size. But after that, for the Walkman, here where it become interesting, and it reminds me the mistake I made in the previous video. So here we put .image here, and 0 will be the Walkman 0. So here how we are going to build our animation. So we go to Walkman 0 like this and paste it. So, and we will go same, do the same for all the next 4 ones. So this is even the 5th one. So here 1 will be 1, 2 will be 2, and 3 will be 3. Finally 4 will be 4. So we are putting all the pictures in the same data type that we created specially for this. So let's get rid of this. Okay, we keep the toggling, but let's keep rid of this command. We don't use this one anymore. We will still try to see the picture of the weird guy with the WeeW. Okay, and after that, let's start playing a little bit with this. So we can play with the position of the Walkman. So what we can do is clear the buffer each time, and after clearing the buffer, I can start here having a for loop for, let's call j equal to 0, j less than 4, because we would like only the walking, and j++. Okay, let's add int I and j just for the beginning. So, and after that, okay, what we can do more, so here for I equals 0, I less than 83. Okay, so this is a small mistake, and I++, what we are going to do is to move each time. Let's put this one, and let's remove the toggle for the moment. So we will be moving for each time we are going to update, so the buffer should be inside the J4. Okay, and here it will be the J as we are selecting the picture. Okay, so here what we can use is Walkman dot x position will be equal to I. So we are going to see how the Walkman will be walking. Okay, let's save, see if there is any mistake or error. Okay, one warning, let's check where is it. Okay, Walkman, yeah, of course I didn't put the Walkman here. Okay, and we need to print. Okay, let's save, check, no warning. Okay, so let's bring the screen and let's make it smaller to see how things will go. Let's save, and just to check again to not have, yeah, I need to put this buffer inside so I can see the change, and I'm putting only 200 milliseconds. Okay, let's run and see what's happening. So we do have the view And we do have a short mistake here, but you can see we do have a nice walking man here. From where this is coming, let's check. Okay, so usually when you see that kind of glitch, better to go back to the C drive where you update the buffer, and probably if you look in the end Y, yeah, so you see here the end Y should be based not on the W, which is the width, but the height, and that what generated this error. So if I save and I run it, good, no error. Let's upload the code, and here you are. So you have a walking wheel, quite in a very perfect condition. So now nothing better is to add some animations and giving some story to that guy. So let's say for I, no, here, so if I is equal to, let's say 30, or yeah, 45 or 40. So if I is equal to 40, let's make it correct here. We are not going to show that, so this is happening for the else, which we will put here and here. Okay, so if the I is equal to 40, we are going to use all this again, but we are going to show the one number 4. And also let's make him talk a bit, so we can take again this update string data, copy, put it here, and we put just WeeW, and let's make it beautiful. So let's add some stars here and some stars at the end. We can put it at the row number 5, and here we are. So, and let him make a delay, a moment of truth of 500 millisecond. Okay, and let's reduce this one a little bit to 100, so we can go much faster to that. So let's save. Okay, so we have our view, and the guy starts running. He is really happy. So let's check if it works. Almost there, man. Yeah, just WeeW. Fantastic. So you can see, guys, you can mix pictures and also text, and it gives you quite a funny situation. Please enjoy, and thank you so much. Finally, I would like to say, if you stayed until the end of this video, you're really an awesome person, because it takes a lot of time to make this kind of video, and there's a lot of details. If you have any question, I will be really happy to answer yours. Enjoy your day. WeeW!